Alrighty. I think actually I might lie. That might not be the last. I don't think that is the last question. Sorry, I was wrong. All right. Climate change and sea level. So during a glacial time period, again, that's when it's colder. That means more water is frozen in glaciers that are on land. So you have more of that thick, giant land ice structures. So that means more of the water is in glaciers, so less of it is in the oceans, and sea level goes down. So during a glacial time period, sea level is lower. During an interglacial, when it's warmer, more of those glaciers melt, that water goes into the ocean, and sea level goes up. So during an interglacial, sea level will be higher. The most recent kind of very dramatic example of that was during the Mesozoic. So that's like dinosaur times. This is kind of what an image of what it looked like during that time period. So you can see Pangea is breaking up, right? So the continents they're not in their current configuration, but Pangea is breaking up. And sea level, and it was much, much warmer. There were very, very little glaciers on the planet. So sea level was way higher than it is now. For example, you can see the whole middle of the United States was covered in this seaway. That's one of the reasons we have like ocean fossils in the Midwest is because there used to be underwater because sea level was way higher. And of course the whole of like the middle America is like underwater, so there's no Panama, no any of that. There's this big seaway that went right through there. So yeah, you can see how much more of the continents were underwater because sea level was way higher. So so we can learn a lot by looking at past conditions, but how do we figure out what past conditions were like? A big one is what we call stratigraphy. This is the general idea in biology that you can look at older stuff by looking further down into the rock or into the sediment. Because you'll have, like, kind of as we talked about, you'll have a layer of rock. You'll have sediment raining down on top of that. That's newer. And over a long period of time, that will actually get turned into rock. And then you have another layer of sediment on top of that. That's newer, that gets turned into rock, then another layer on that, then another layer on that, then another layer on that, then another layer on that. So if you're close to the surface, that is newer rock or sediment. And if you go down deeper, this is older rock or sediment. So that's basically the idea of stratigraphy. If you're going deeper, you're going further back in time. So one of the ways we do this is with sediment cores. Sediment cores, we'll actually do this when we look for sand crabs, although at a much smaller scale. You basically, it's almost like taking a straw and sticking it into the ground, and then you pull it out and you get this big tube of sediment. And of course, the one that was furthest down would be the oldest. The one that's higher up at the surface would be the newest. And so you can look for what you find in that sediment in order to kind of piece together what was going on at the time. So you can do things like looking for little fossils or microfossils. You can look at what the sediment is made of, like is it made of basalt or silica or other things. You can also you can analyze it chemically to figure out a lot of different stuff about it. Um, and yes, you can get a lot of clues of what was going on at various time periods by looking at sediment cores. I recommend taking a look at this if you're interested. This is actually a really cool sediment core that shows the uh, in the sediment shows the effect on the sediment of the asteroid impact that killed the dinosaurs. So everything from like the massive amounts of sediment that was flung all over the place from the asteroid actually hitting to there was like a bunch of glass because so much of like sand and things like that just instantly got turned into glass by the heat. So there's all these like little pieces of glass in there. The sediment cores from the time the dinosaurs died was like very. So another thing we look for in sediment cores are things from biology, because stuff left behind by living things can tell us a lot about what was going on at the time. So organisms can leave behind those shells, like I talked about with the phytoplankton, the silica shells and the calcium carbonate shells, but also bivalves, so things like clams, oysters, mussels can also leave behind their shells. And these are generally inorganic, so they don't like rot and decompose. You can also find things like pollen or fossils as well. So I'm not going to go into a lot of detail on this. Your book talks about this a little bit as well. When you're looking at these little biological things left behind in sediment cores, they can give you a lot of cool clues about what was going on. For example, they can be an indication of was it hot or cold, because certain species like the heat, certain species like the cold. So depending on what you find there, will probably indicate if it's hot or cold. Whether an area of ocean was covered in ice. So like, did sea ice extend to there or was it uncovered? How close was an area to dry land? So again, what was sea level like? Was sea level lower, and so the ocean was further away from this point, or was sea level higher, and so the ocean was like closer to that point? What were the nutrient levels like? And yeah, an overall sea level as well. So all these things can, all the biological stuff can give you all these kinds of really cool clues. Like for example, if you find, little phytoplankton shells, that means that area at that time period, that area was underwater, right? Because that's the only way you're going to get phytoplankton, the little shells. All right, next, the last section for this lecture is going to be about bathymetry. So bathymetry is the measurement of the depth of the water in ocean, seas, or lakes. So topography, that is mapping out like mountains and valleys, like it's the, up, down shape of the land. Bathymetry is just the same thing, but for underwater. So you're mapping out the physical shape of the ocean floor or lake or river, and it lets you map the seafloor features. So for example, this is the bathymetry of San Francisco Bay. So here's where the Golden Gate is. This is San Francisco. We're of course located like down here in kind of San Jose area. And so you can see like over here, it's much shallower, but then you have these deeper areas carved through, going north and south through the bay. So it's showing you again the shape of the seafloor of the bay. Next question for you guys is why would we want to map the ocean floor? What do you think a reason is that that's like a useful thing to map out?